Hey everybody, welcome to this new video on Amazing Mac stuff, working with OpenGL. I think I will change the name of this series from starting with Jitter by simply like OpenGL in Macs, because now we are doing not really basic stuff. We are going to see some stuff that is kind of starting to be advanced, so there is no reason to call this starting with Jitter again. This is getting a bit more advanced. So, in this video we are going to see the JIT.GL multiple objects, so how to create multiple spheres with our cubes or whatever without having to actually create all the grid shape objects. And we are going to see like a very basic usage of the JIT.GEN object. I mean, not really very basic, but kind of we will start to scratch the surface of the JIT.GEN object. Okay, so let's start. I want to delete a bunch of stuff in this patch. Yeah, so I will actually do something like that. I will do a save as, and this is OpenGL 5, and right, so I will delete these spheres. Alright, so now we just got the lines from the sketch are still drawn, and that's okay for the moment. So since we are going to create the spheres using the JIT.GL multiple object, it's okay. We don't need the single sphere elements as we did in the previous patches. So let's go on. Let's create a subpatch and call this multiple. There it is. In here we will create our JIT.GL multiple object, and we will see how to draw multiple spheres using that object. So let's start. First, of course, we need a JIT.GL multiple object, and it needs the name of the world, of course. Okay, so how does this object work? So it takes a matrix or several matrices as inputs, and according to the dimension of the matrix, it will render as many objects as are the dimensions of the matrix. So for example, if we create a JIT matrix 3 float 32 10 by 10, and we connect these, we fill this matrix with some positions, and we connect this to the JIT.GL multiple, it will draw 100 objects. Okay, so first of all we have to create the object that the JIT.GL multiple is going to draw, because it doesn't know which object it has to draw. We have to tell him. So let's create a JIT.GL grid shape as we did before. So my world, but this will set it to automatic 0, because we don't want this object to automatically draw on the window. We want the JIT.GL multiple to use this object. If this will be kind of a dummy object, then the JIT.GL multiple is going to draw on the window. So the object doesn't need to draw itself. Let's actually give it a color. So let's make this white, and we can actually also attach a JIT.GL material to this object to make it look cooler. So my world, that's it. Let's give it a diffuse color, so matte diffuse of white. Okay, now in order to make this object drawn by the JIT.GL multiple, we have to connect the output of the JIT.GL multiple to the object, and this is one way we can do that. Otherwise, we can give to the JIT.GL multiple the target name attribute, like for example sphere, and then we give a name to this object which must be the same. So this object has the name sphere, the target name of the JIT.GL multiple is sphere, so the JIT.GL multiple will draw this object. Alright, so that's not all of it, because first of all we need to tell to the JIT.GL multiple how many parameters is it going to modify for the objects it draws. For example, if we say 1, it means it will have only one input and it will modify only one parameter. And we have to say which parameters it has to modify by using the attribute GL.params. For example, let's say that we want to modify the param position. Okay, so now this matrix here is 100 zeros. So the matrix is full of zeros. So it's simply going to draw 100 times this sphere in the center. So if we use like a JIT noise, 3, float 22, 10 by 10, and why 3? Because we need 3 axes, right? We need x, y, and z for a position in a 3-dimensional space. So basically, since he knows that the first input is relative to the position parameter, basically the position attribute, and the position attribute takes 3 numbers, we use a 3 planes matrix in order to fill all these parameters for the position attribute. So let's try with noise. All right. So now we are drawing 100 spheres on a range from 0 to 1 on the x and on the y axis. Let's actually create another light so we can have kind of a better vision of what's going on. So I will simply go inside the light subpatch, copy this light here, and put it at a position of 0 to 0, something like that. Let's maybe make this directional. Okay, so now there is a directional light that comes from here. Actually, the position doesn't really matter anymore. Okay, so this is our kind of our fixed light for the moment. Fixed directional light. Okay, this we use just for this patch. Maybe I'm going to use it in the future, but anyway, it let us kind of have a better vision of what's going on. Our point light is still going around. We can maybe try to change the color of this directional light, or maybe actually let's change the color of the point light. So diffuse. Let's make this slightly reddish. It's too few. Something like that. Yes. And let's change also the color of the sphere that kind of represents it. Alright. So the point light will create this color, and the directional light will just create a white light on our spheres. Okay, this looks good. This looks pretty good. So let's go back inside multiple. Now, all these spheres are overlapping into each other because they are simply just being drawn into the center, and they have a scale of 1, and they have been drawn into a position range of 0 to 1. So we can do a couple of things to prevent that. Now, we didn't introduce yet JIT.GEN in this series, but I would like to introduce it now, and we will do a super simple thing with it. So let me give you first an introduction, to a very short introduction to JIT.GEN. I think we will grasp the concept when we kind of encounter them, but for the moment, we will do just a super small introduction. So with JIT.GEN, you can do you can do operations on matrices. So what does this mean? If you double click on this object, inside the object, you can write what this object should do with every single cell of a matrix. And this environment is anyway a bit different from the max environment. It's not the max environment. It has some different rules, has not the same objects at all. It works in a different way. So basically you have to think that inside the JIT.GEN object, so if you double click on it again, it will open this window. Inside this environment, you can create an algorithm to work on the single cells of a matrix. For example, by default, it just sums together two matrices that come in the inputs. Now, I have some videos on JIT.GEN. I will link them in the description. I recommend you watch them. But anyway, for the moment, we are just using it in a pretty basic way. So what I want to do is to multiply by 2 the input of the noise, which is by default between 0 and 1, right? Between 0 and 1. So when we multiply by 2, it just goes between 0 and 2, right? When we subtract 1, it will go between -1 and 1. So we actually rescale the range of the noise in a way that goes between -1 and 1. In this way, it doesn't go only on the positive axis, it also goes on the negative. So let's connect the JIT.GEN in between the JIT noise and the JIT matrix, and boom. All right, but it also go a bit below. So let's actually sum a quantity to the epsilon for them to go a bit more not below the plane, right? And okay, so now bear with me, we're going to use the width operator. So the width is a bit like unpack. For example, we know that this matrix that comes inside has 3 planes, right? And we want to operate on the single planes. So what we will do is to use the JIT unpack object, which unpacks the single planes. And inside JIT.GEN, we can select the planes we want using the width operator. So how does this work? Basically, width x is the plane 0. Width y is the plane 1. And width zeta, I always write width, is the plane 2. Alright? So if we say width x, we are widthing the first plane, which will be the x position for our spheres. Alright? Then let's actually width the y, and let's width the z. Now we say we want to add a small quantity like 0.5. Actually, we probably want to add 1 to the y, and then we have to pack this back together. Now there is no JIT pack inside JIT.GEN. There is an object called vector, which is like JIT pack basically. So we write a bunch of zeros inside. Oh, and in JIT.GEN there is no like integers and float. Everything is by default float. So I know it's a lot of infos, but you don't have to remember all of these. We will see these a lot. JIT.GEN, this is just a fast introduction to the object and see how we can use it quickly. But I think you can get a kind of grasp it how it works by simply seeing me using it. So basically, let's write this down. Everything is float inside JIT.GEN. Okay, so it doesn't matter if we don't put the dot. You can also put the dot, but it's really not necessary because anything is anyway float. So let's connect these to the output. The x and the zeta, they remain untouched. Then we do that. And as you can see, it went up. It went up. Let me actually delete these the lines. Okay, so now they're gone. Okay, cool. And so, okay, the problem now is that these spheres are too big. They just overlap with each other. So what we can do in the JIT.GL.MULTIPLE is to say, actually we need another parameter to control. And this will be the scale. So now there is a second input, as you can see, because I put a 2 here, which means we are controlling 2 parameters. Alright. So actually we can even delete this matrix because we don't really need it. Let's connect this directly to the JIT.GL.MULTIPLE. Since the JIT noise already outputs a matrix, and a JIT.GEN 2 is a matrix object. So now let's create another output inside JIT.GEN. We can create as many outputs as we want. I think so. I don't know exactly what is the limit, but you can create a lot of them. So let's say that we want to scale these spheres on, for example, 0.1. Then we create a vector tree. So this will scale the x, y, and zeta dimensions of the object. We connect this here, connect the second output, let's make this bigger, connect the second output to the second input of the JIT.GL.MULTIPLE, we press on the bang, and there it is, we have our small 100 little spheres. Let's actually spread them a bit more, so we can do that by multiplying the output of these for something, like for example for 5 by 5. So let's do it. Boom. Okay, now they are really spread. Now they are really spread. Maybe 5 is a bit too much. Let's do like 3. Okay, and of course we have to add 3. We have to add 3 to the y, so they will not go below 0. Okay, even if actually I would like the spheres to be a bit more centered, so what I will do is to just lower a bit the plane here, exactly. Then on the multiple, I will say simply +2. All right, then I bang again. Okay, now they're a bit more centered. Let's actually say +1. What do if we do +1? Because anyway scaled. Let's do +1.5. This should be okay. All right. So now we have our little spheres. The light is going around in the sphere. Let's actually make the light a bit smaller. So let's scale the sphere that kind of represents the light. Let's make this a bit smaller. So 0.3. It's a bit too small. 0.5. Looks about right. So we got it. So this is how basically the JIT multiple works. Let's actually for a moment disable the directional light. Okay, very nice. So we can see spheres illuminated only by our point light that goes around inside them. Okay, this looks pretty cool, I will say. Okay, and then another thing that we can do is to go inside a JIT.GL multiple, and we could, for example, draw a line between the spheres using, for example, the sketch object. Right? We could do that. Okay, yeah, let's do it with that. There is a better way to draw lines between objects, but I really want that we still kind of explore a bit more the sketch objects. So I will delete these, what we did last time, and let's do like that. Let's send the matrix. So position matrix. Out of this, let's receive it inside the sketch subpatch. And we will put a jit.iter, right? Is this what we want to use? So iter basically translates a matrix as list or values. Iterates through all the cells of matrix, sending a message for each cell out of outlet. Okay, for example, if I say print out of the left outlet, we should see all the positions of the single objects. So what did you give us? Nothing. I probably made a mistake with the name of the receiver. So position positon. All right. Okay, again, bam. Okay, perfect. We have the position of all the spheres. Should be 100 of them. Okay, cool. So if we go inside here, then we can do something like this. So we can do something like that. Let's do a trigger list bang. So first we send a bang, and then we send the list. So basically the name of the matrix. Now the bang will trigger the reset message to erase the list of commands to the JIT.GL.SKETCH as we saw in the last video. And then from here we will say prepend. Of course we have to make in couples. So let's do something like this, ZL group 6. So every time we receive 6 elements, the ZL group will output a list of 6 elements. So let's actually try that using print. Let's erase the console. Go in the multiple, bang. Okay, we have a list of 6 elements. So every basically couples of spheres will be coupled together, and we can use them as positions for the sketch. So let's do like that. Prepend line segment. And it should work. So let's attach this to the JIT.GL.SKETCH. Let's go inside multiple, bang. All right. All right, now every one of these lights of the sphere is connected with a line. Let's do it again. Boom, boom, boom. Let's make the line width a bit smaller, like 2, for example. Let's go into multiple, bam. Okay. Okay, this looks right. Okay, there's already a lot of information in this video. I would like to cut it right now. And in the next one, we will see how to actually start to move those spheres around, and with the line attached, we will see a new way of drawing the lines without using JIT.GL.SKETCH, but using actually the JIT.GL mesh object. And yeah, we will see even more stuff on how to use OpenGL in Max. Maybe first, before we quit, we can do something like that. We can create another JIT noise with only one single plane. This will be our scale noise. So we will use this noise for scale the spheres. So they have all a different, size. So let's create another input on the JIT.GEN because we can create as many inputs as we want, I think, again. And okay, so let's actually, this will be anyway the same. This will be the same plane copied 3 times, because basically every matrix that comes on the right of a JIT.GEN, so on one of the inputs in the right, will be basically we'll have the same number of planes and the same dimensions of the matrix that comes in the left, so will be automatically scaled. So we just are interested in one plane, so we're going to take this one single plane, the first one, anyway, they're all the same, using suites X. And we are going to multiply that by 0.2, and then we are going to add a little offset in order to not have spheres with the sides of 0, right? So let's do like this. We connect this to all the 3 outputs, to all the 3 inputs of the vector. Bang again, and now our spheres should have different sizes, which they don't do. Okay, let's make the range a bit bigger, so let's not add these, let's add a smaller offset, see what's going on. Okay, this looks about right. Let's maybe multiply them for something bigger, like 0.3, oops. And okay, now all the spheres have a different size. Let's maybe make them going a bit farther from each other. Alright, and then let's add like a value of 2.5 maybe here. So just experimenting with the numbers, that's a bit too much. Let's say 2. This looks alright, this looks alright. So that's what we got. Every sphere has a different size, okay, based on a random value. We could do this also for the colors, of course. We can do it for basically every attribute of the sphere object. So this will be, with this we will of course see in future videos. So okay, this looks pretty okay to me. And let's stop it here, and we will continue in the next video. If you have suggestions, critics, whatever, please write them down in the comments. And if you want, you can visit my Patreon. I could not afford to make all these tutorials without my Patreon channel, so that's really great. So you can check my Patreon and take some patches from there. You can join the Discord channel and so on. Link in the description. Anyway, thank you for following this video. For whatever thing, just write me, and see you in the next one. Ciao, guys.